Hello everyone, and welcome to Part 9 Function Exercises Solutions lecture, where we're going to be going over the solutions for the previous function exercises. Let's go and open up the file to get started. Okay, here I am at the function exercises file. Let's start off with problem 1, which was, remember, if we wanted to have a list of integers, we need to return true if the sequence of numbers 1, 2, 3 appears in the list somewhere. And basically for this one, what we're going to be doing is iterating through the list 3 at a time. So let's show you how we can do that with this array check function. I'm going to say for I in range, and then I'll go for the length of nums, because I don't know how long nums is going to be as a list. And then I will say -2, because I don't want to go all the way to the end. I just want to go starting from here. So I will go -2 back, because I'm going to be counting in steps of 3. So let me show you what that looks like. I will say if nums at index I is equal to 1 and nums of I plus 1 is equal to 2 and nums of I plus 2 is equal to 3. In that case, then I return true. If that never happens, meaning I never get a return true inside of that for loop, then I will just return false. And notice how this return false statement is in line with that for loop, which means this entire thing has to run through, and if we never get a return true here, then we never actually break out of this, and then we go to return false. Okay, so that's the basic idea. Again, length of nums -2 because I'm hopping over in steps of 3, and if I went all the way to the end, I would get an error because I'd be indexing outside of the actual list. The last one I want to go to is right here, length of nums -2 indices back. That way I can do the +1 and +2 checks. Alright, now let's go on to problem 2, which was given a string, return a new string of every other character starting with the first, so hello yields HLO. Okay, now as a quick moment, there's many ways you could do this. In fact, you could just use a slicing notation, but let me show you a really standard way to do this with just a loop. And this one will work across any language. We set an output to be result, and then I will say for I in range, length of the string str, and actually str isn't a good choice here, so I will say my string and change this to be my string as an input. And then I will say if I mod 2 is equal to 0, result is equal to result plus my string at the current index, which is I. And then I'm just going to return the result. So this is a very basic algorithmic way of solving this problem. The other way you could do this is by actually using slice notation by skipping every other letter. So it would be something like : 2. So again, here we're saying for I in range, the length of the string, if I mod 2 is equal to 0, meaning we're on even numbers, result is result plus my string. And this is kind of the same thing as just saying my string : 2. Alright, now let's continue on to problem 3. Problem 3, we were given 2 strings and we wanted to return true if either of the strings appears at the very end of the other string. And we could ignore case sensitivity here. So what we can do is, since we're ignoring case sensitivity, right away just make them both lowercase. So I will say a is equal to a.lower and b is equal to b.lower. And then I'm going to say return, and there's 2 ways we could have done this. We could have used the special ends with method. Now we didn't actually cover the ends with method, so you may not have been aware of it, but it looks something like this. You can say b dot ends with a, and, or I should say, or a ends with b. And that's the way you could do it with the most Pythonistic code, using that ends with method. But we'll pretend that you didn't know that, since we didn't really cover it, and show you the more algorithmic way of doing this. We will say return the string A minus, this is indexing, the length of B all the way to the end. And so what this basically is doing is it's asking, does the string A minus length of B all the way to the end equal to B? Or is A equal to B minus length of A all the way to the end? So all we're doing here is we're checking, is A equal to B with the ending part removed? And that basically tells you, does it end with it? So take your time. This syntax may look a little weird, but this is all we have to really do. Again, all we're doing here is we're saying, for this, does the string B equal to the length of B all the way to the end with the negative indexing, which basically allows us to go backwards. And essentially what we're saying, if we look up here at this example, if I have the string ABC and the string hi ABC, I want to know, does the end of this string right here equal the end of this string? So I'm using the length of this string to check what's going on with the equal length over here, which is why we have a negative starting from the backwards, or starting from the last index position, I should say. All right, so take your time with this one. This one's a little smoother, and this one's more algorithmic. Okay, now for problem 4, we wanted to say, given a string, return a string where for every character in the original, there are now 2 characters. So what we can do for this is we'll create an output string called result, which is just an empty string. And then we'll say for character in my string. And what we're going to be doing here is taking the result, which is an empty string, and then adding to this string character times 2. And then all we have to do is at the end of this, return the result. And that's how the double character can work. So all we're doing here is essentially continuously concatenating result with the double of the character. Then at problem 5, what we wanted to do was, given those 3 integer values, a, b, and c, return their sum, except for those special rules, and why this was called the no teen sum. So we had also the option to create this helper function. So let's show you what we could have done here. So for this first one, this no teen sum, what you could have done was say return, and then we'll say fixed teen A plus fixed teen B plus fixed teen C, where what fixed teen is, what it's actually doing is just a helper function. So in this way, we keep avoiding writing repeated code. We practice the dry principle, don't repeat yourself. Again, let's focus on defining this helper function, fixed teen, which really does most of the dirty work. So what we can do here is say if n is in 13, 14, 17, 18, or 19, that was the conditional list based off of the instructions, we want to return 0. And if that's not the case, then what we're going to be returning is the actual number n. So what this does is it calls fixed teen on each of the 3 numbers, and what fixed teen itself does, it checks if n is one of these numbers, and if it is, it just returns 0. Otherwise, it returns the number itself. And then what we do to actually call this is call no teen sum along with this fixed teen. Otherwise, we'd have to write this code 3 separate times in no teen sum. All right, now on to problem 6, the last problem. For this problem, we wanted to return the number of even integers in the given array. So this one's actually quite simple. So let's start off by making a variable called count, and we'll set it equal to 0. And then after that, we're going to say for the element in nums, or for every num in nums, we'll say if that particular element divided by 2 has a remainder of 0, meaning it's even. So when I say divided by 2, I really mean remainder, I really mean the mod modulator. I'll say count gets another one. And then after all this, we're going to just say return the count. So again, all I'm doing here is I'm setting a count equal to 0, going through the elements. If the element is even, meaning element mod 2 is equal to 0, add 1 to the count, and then just return the count. All right, that's it for this. If you have any questions, feel free to post to the Q&A forums, or just check out the solutions lecture, which has more code and some explanations. Thanks everyone, and I'll see you at the next lecture.